Good morning, my dear students. You are welcome to another mathematics lesson with Mr. Emmanuel Akpan. Today we are going to consider the topic probability. The topic is what? Probability. Probability is a very interesting topic, so I urge you to be with your new concept mathematics 3rd edition. We are on chapter 22, page 255. Okay, with other writing materials that will help you to assimilate the lesson. All right. Now let us consider the behavioral objectives of this lesson. At the end of this lesson, you should be able to mention and discuss chance events in everyday life. For instance, power failure occurring at any time of the day. Discuss basic probability concept, example, possible or likely event, sure event, independent event, etc. Define probability as a measure put on the occurrence of random phenomena and determination of sure event. Example, tossing a coin. State basic fact about probability. For instance, the probability of an event is always between 0 and 1. All right. With that, we'll move straight to what we have. That is, chances in everyday life. Okay, chances in everyday life are events that occur without we having full control of it. It happens by chance. Okay, and then we are going to look at some of them. There are numerous, endless events that happen by chance in our daily life. Okay? The first one is that the referee tosses a coin to decide the team to pass the ball first. Whenever they want to play football, officially, the referee will call the two captains to the center. You always notice that, and he will toss a coin to decide the team that will pass the ball first, to avoid any controversy. And when he's tossing the coin, he's not the one that decides the side of the coin that will show up. Okay, it happens by chance. Now, when we take examinations, we may either pass or fail. We cannot pass and fail the same examination at the same times. When we embark on a business, we may either succeed. All right, I said that when we take examinations, we may either pass or fail. We cannot pass and fail the same examination at the same times. Two things are involved. It's either you pass or you fail. So always endeavor to pass your examinations. Now, when we embark on a business, we may either succeed or fail. For the fact that another person is succeeding in that business does not mean that you too will succeed. And also, someone failing in a particular business does not mean that another person cannot succeed. Okay? Now, another one is that a man either lives or dies. No two ways about that. You either live or you die. Now, another chance event in our everyday life is rain falling at any time without anybody knowing that rain is going to fall. Okay? Now, let's proceed and look at other chances in everyday life. A mother expects a baby. Take note that I'm saying a baby. Now, when the baby is delivered, it may either be a boy or a girl, and not both. Okay? Somebody may say, how about twins? Remember, I'm talking about a baby. Tunde shoots at a bird. He may either hit or miss it. Okay? Now, when one contests in an election for a political post, one either win or lose. No two ways about that. Like the chairmanship election, you've heard about the results of the primaries. Only one person will emerge as the winner, and the other person will lose. So it is a risk. Probability helps us to ascertain the risk that is involved in any undertakings. It's very, very useful. Power failure occurring at any time of the day. You can agree with me that in a society, in a country, power failure can occur at any time without any apology to anybody. Okay? And those are chances events in our everyday life. Now let's look at basic probability concept. In order to aid our understanding of the concepts of probability, the following should be understood. Possible or likely events. These are events that may possibly happen. You've heard someone saying, possibly I'll be there. That means the person is not sure. Possibly. Okay? Will you be in school tomorrow? Possibly. Meaning that it's under probability. Number two, equally likely events. These are events that have equal chances of occurring. For instance, in the toss of a coin, you get to see the picture of a coin and understand what I'm trying to say now. In the toss of a coin, it's either the head, that is where the picture is, or the reverse side, the tail, that will show up. The two cannot show up at the same time. Okay. There are some children that will cut a leaf when they want to play football. This side will say, I'm taking this side. This one will say, I'm taking this side. And they will throw it up. When it falls down, they will check the outcome. So the act of throwing up is a trial, and what will show up now is the outcome. Okay, it's not possible for both sides of the leaves to show up at the same time. Impossible. Now, certain or sure events. These are events that will surely happen, no matter what. For instance, every man that is born of a woman must surely die. This is a sure event. You cannot escape it. Okay? Impossible events. These are events with all certainty will not happen. Okay? For instance, a human being with 4 legs, or a lion giving birth to a goat. Is that possible? No. It's practically impossible. Those are impossible events. Now, independent events. 2 events A and B are said to be independent if the occurrence or non-occurrence of A does not affect the occurrence or non-occurrence of B. Alright? So, the 2 events are independent. Okay? For instance, if you toss a coin and you roll a die, okay, a head can show up in the coin, the number 6 can show up in the die. Head showing up in the coin cannot prevent this number 6 from showing up, because they are 2 independent events. Now, this one is very, very interesting. Mutually exclusive event. This is the opposite of independent event. 2 events A and B are said to be mutually exclusive if A and B cannot occur simultaneously. Take note, this is simultaneously. Alright? Now, as a student, you can either be a day student in our school, Bright Future, for instance. You can either be a day student or a boarder. You cannot be a day student and a boarder at the same time. No, that is not possible. You have to be decisive. Okay? You have to take a decision on either to be a day student or a boarder. Can you guess another mutually exclusive event? Okay? You cannot be in school and also be in your house at the same times. Is that possible? It's not. Another thing is that you cannot be in Lagos at the same time being in Abuja. Your being in Lagos will automatically prevent you from being in Abuja at the same time. So take note. So those are mutually exclusive events. Okay? We are making progress. What is sample space? Sample space is a list of all possible outcomes of a given experiment. For example, suppose a balanced die is rolled once. The sample space for this experiment becomes S is for sample space, and this is the notation. You put it in a curly bracket and you number it with a comma. Okay, these are the possible outcomes. You know why? The die, that die that they use when they are playing Ludo, is numbered from 1 to 6. It's numbered from 1 to 6. Okay, the faces are numbered from 1 to 6. You see dot, 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 dots. Now they turn to 4. And when they are playing, people always call for the number 6. They will say 6, come out. Okay, do you have that experience? And they like using a pair of die. Okay, a pair of dice rather. They use that. They are always 2. So when they are playing, they will say 6 come out. So the faces are numbered from 1 to 6. That is the total outcomes. Okay, they call it sample space. Also, suppose we toss 2 fake coins once. The outcomes of this experiment is shown in table 8.4. You know that a coin has head and tail. That's 2. Another one has head and tail. So if you are throwing 2 coins once, you have 4 possible outcomes. That is 4 sample space. So in this table, this is the first coin and this is the second one. This one has head and tail. This one also have what? Head and tail. You pay them. It's more like multiplication, but it's not actually multiplication, because there are instances you may have to add up the numbers. So you pay. Pick this one, pay with this one, you have this. Pick this one, pay with this one, you have this. Now you pick the head, the tail rather here. Pay with this one, you have this. Pick tail and tail, you have it here. Okay, now let me show you the region that is the sample space. Okay. Now, this part here, this part that you see here is where you have the sample space. Therefore, 1, 2, 3, 4. Okay? Let's make progress. Now, the sample space now becomes this. Okay, we have said that. Notice that tossing a fake coin twice and tossing 2 fake coins once will give the same sample space. A simple explanation is that if I want to give you 2,000 naira, I just give you once. How much is that? Is it not 2,000 naira? But there's somebody that wants to give you that same 2,000 naira. He or she will give you 1,000. Another time he will say, take another one, making it 2. At the end of the day, what you are getting is what? 2,000 naira. So that is what we mean by tossing a fake coin 2 times. First one, second one. But then tossing 2 of them once, it gives the same outcome. Now, what is an event? An event is a subset, or you call it part of the sample space, chosen by a given rule. Now, let me explain that. In a toss of 2, let me correct that. Okay. Remove this one here. Okay. For example, in a toss of 2 fake coins, let E be an event that at least 1 head occurs. Thus, event E becomes this. Now, remember that sample space. Can I take you back to it? Let me take you back to the table. This is the sample space. Now, the events, what they are looking for is that head will appear at least once. At least once. Here, this one at least one head here, there's another one here, there's another one, but it's not here, making it how many? 3. 1, 2, 3. So the event is part of the sample space. Okay, so this is the event that at least one head occurs. Now, definition of probability. The term probability refers to the study of random experiments. In other words, it is the measure of chance or likelihood that an event will happen or not happen. It is usually given as a fraction. Okay, that means that probability tries to look at the possibility of events taking place or not taking place. Okay, like if I apply for that work, what is the probability that I'll be absorbed? What is the probability that they will take me? You know, it's always very funny when they want to do recruitment in a country, maybe road safety, for instance. They say they are looking for 3,000 people, and you see the whole country will apply for the job. So what is your chances of getting it? That is when they will now doing all sorts of permutations, taking it to the local government, taking it to the wards, taking it to giving it to stakeholders and the rest of the thing. So your chances of getting a particular thing or not getting it is what probability is all about. It's a measure. So apply probability in your daily life and you'll never regret it. Now, what is the mathematical expression for probability? Probability of event, that's PL of event, is the number of required outcomes over what? Number of possible outcomes. Okay, let me correct that. Okay, let me correct that. This is outcomes. Okay, so I say that mathematically probability of event is given by number of required outcomes over number of possible outcomes. The number of required outcomes is the event, whereas the number of possible outcomes is the sample space. So you can also write it total number of favorable events over the sample space. Don't worry, when we are going to apply these expressions, you understand it better. Okay, let us consider example 1. Suppose a fake coin is tossed twice. Determine the sample space and the probability of getting at least one head. A fake coin is tossed twice. Determine the sample space and the probability of getting at least a head. Now, fake die means it is fake coin rather means that it is unbiased. You can still differentiate the part that the picture is and the reverse. Okay, very good. This is picture of a coin. Those of us that were born in the 90s or thereabout, we've used coins before in our transaction. Okay, this part that you see the picture of the person used for the coin is called what? The head. And the reverse, where nothing is, the picture is not there, the human face is not there. Okay, that's the tail. It always has two sides, this side and this one. If you have not seen it before, you can look for it. You can equally ask your parents or whoever to show you what a coin is, so that you can link it up with this. Now, since we have a fake coin that is tossed twice, okay, this is the first one and this is the second one. This one has head and tail, this one has head and tail. So we pay them. This we have this one and this one, we have this one and this one. this one, and this one. I've explained this before when we are looking at sample space. So the colored region is where we have the sample space. Now, I've written it out for you to see. Look at everything here is written out. Okay. Now the event, that's what is required in that question. What is required? They say at least one head. That's wherever you see H, that is representing the head. Is here, is here, is here, is not there. It's not here rather. So we have 3. So there are 3 events and 4 sample space. So probability of event, total number of favorable outcomes, number of sample space is reduced to this form: number of events, number of sample space. So how many events? 3, sample space 4. So our probability is now 3/4. Okay. If they needed probability of 2 heads, we have only 1. That would be 1/4. And with this table, you can find the probability of anything relating to this particular question. I hope you understand. You write out the sample space, pick what is required in the question, and you put it in the formula. We move ahead. Example 2. If a die is rolled, what is the probability of getting an even number and odd number? So, this is a picture of a die. The faces are numbered from 1 to 6. This is a die, this is a coin. So we are concentrating on this. So as usual, we write out the sample space is numbered from 1 to 6. So looking at this one, an even number. How many even numbers do we have? 2, 4, and 6. So there are 3 even numbers. Okay? So the probability of even number is now number of even numbers. That's how many even number of a number of sample space. We have 3 here, so 3/6. Remember, 1, 2, 3, 4, 5, 6. There are 6 in number. Okay, 3/6. You can reduce that. 3 cancel is 6, 1 cancel 6, 2, and that's 1/2. Okay, so what's the probability of obtaining an odd number? Oh, yes. How many odd numbers do we have? 1, 3, and 5 are odd numbers. Altogether, we have 3 odd numbers. So probability of odd number is number of odd number of sample space, and that is the same thing, 3/6, and that gives us 1/2. In other words, if a die is rolled once, the probability of getting an even number is the same as getting an odd number, since the even number is equal to the number of odd numbers in the roll of a fair die. Okay, so I want you to note that the plural form of die is dice. Okay, dice. This is dice. That is the plural form of die. A die is dice. Let's make progress. Example 3. In 2 tosses of fair die, what is the probability that number 4 turns up at least once? I'm going to be a little bit fast. Okay, 2 tosses of a fair die. That means when you toss it the first time, you write the event, toss it the second time, and you also write the event. That is why we have 2 events here. So you record the 4 that occurs on the first one, record 4 on the second one, and the total event will be the summation of the 2. Okay, let us present that in a tabular form. Okay, this is the table. This is the first die, numbered 1 to 6. This one is also numbered 1 to 6. And you pair the numbers. Pick 1, pair with 1. You have this, pair with 2, 3, 4, 5, 6. You see it? Now you pick 2, pair with 1. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, till you get to 2, 6. Pick 3, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5. You do that till you get to the end. 6, pair with 1, 6, 1, pair with 2, 6, 2. As in you pair the 2 dice. I want to believe that you understand the operation, the modus operandi. 6 goes with 6. We have 6 dice in this order. Okay. Please take time and study the table. When you pick this one, pair with this one, write it here. Pick this one, pair with this one, write it under it. And we have gotten the table. Now, the shaded, the entire area that is shaded with the green is the total, the sample space, or you call it total possible outcomes. There are 36 in number. It's more like saying 6 multiplied by 6. That is 6 by 6, 36. Okay? Now, looking at the table, we are looking for where 4 appears at least once. Okay? And look at it here. Wherever you have 4, read down. This is 4. Take it down. You have 4, 4, 4, 4. And you also meet 4 here. Go this way. You can see I've colored it. Let's count it. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11. When you are counting horizontally, you have counted this one here, this particular one. Okay? So when you want to count it vertically, you don't need to count that one again. I hope you understand that. So the total events is 11. Then total sample space, sample space is 36. So the probability will be 11 over 36. Okay? Probability is 11 over 36. This example is a bit advanced. So take time and study it, because this table here is very useful. With this table, you can answer as many questions as possible. Okay? Basic probability concepts. Okay? The probability of an event is always a number between 0 and 1. This tells us that the probability of an event is never negative. If you are finding the probability of events, the answer cannot be greater than 1 and cannot be less than 0. So when you be finding probability, if you have answer to be 3, 4, or thereabout, or -1, know that you are wrong. It's not correct. The sum of probability of all events in the sample space must be equal to 1. Okay. When you are finding all the probability in a particular question, sum them all the answers up, you have 1. The probability of an impossible event is 0, while the probability of a sure event is 1. Okay? So, probability of impossible events, for instance, in a die, is numbered 1 to 6. So, what is the probability that 8 will show up? Is 0, because 8 is not in the sample space. That's impossible event. Now, sure event, when you are very sure that something will happen. Like I said, every man that is born of a woman will surely die one day. That's 100%. That's why we have 1. 100% means 100 over 100. Cancel the zeros and you are left with 1. If the non-occurrence or complement of an event A is represented by A prime, then probability of A prime is equal to 1 minus probability of A. Okay, I'll explain that. It means that if you know the probability of event, then finding the probability that that event will not happen is not a problem. You have to subtract it from 1. Okay? You'll be seeing this expression when we're solving problem. Okay? The probability that events will happen is 3 over 4. What's the probability that it will not happen? That is 1 minus 3 over 4. And that will be what? 1 over 4. Okay. Now, sum of probability happening, not happening, must be equal to 1. With that, let me explain these further problems to you. A bag contains 2 black balls, 3 red balls, and 6 white balls. A ball is picked from the bag at random. What is the probability that it is black, red, white, red, not black? Okay. Picked at random means you close your eyes and pick it without any partiality. Okay. Now, when you have this type of problem, what do? You first of all find the total number of balls. Okay? First of all, find the total number of balls. Okay, let's say total balls. Let us count it. We have 2 blacks, 3 red, and 6 white balls. So 2 plus 3 is 5 plus this is 11. So, we have gotten the total number of balls. Our sample space is now what? 11. So probability of picking black will be how many blacks over how many 11s? I mean the total number of balls. So probability of black will be what? 2 all over what? 11. Now, probability of red will be what? Is going to be, how many reds do we have? 3. 3 over 11. Probability of white, how many whites? Is 6 over 11. Okay? Probability that it is not red. Not red. We have gotten the probability of red to be 3 over 11. So not red will be what? 1 minus 3 over 11. And your answer is what? 11 minus 2 is 3. No, it's 8. Sorry about that. Yes, 11 minus 3 is 8 over 11. Now, probability that it is not black. Not black. Probability of black is 2 over 11. So probability that it is not black will be gotten by subtracting it from 1. Okay. So this type of calculation is very simple. Just say 11 minus 2. You have 9 all over 11. Okay. Another way you can do it, another way you can perform the operation, probability not red means it's either white or black. That is 2 plus 6. We have 8. Probability not black is either red or white. That is 3 plus 6. 9 over 11. Okay. Suppose if fair die is tossed 1, find the probability of obtaining the number 5, 8, even number, odd number. Okay. Let me briefly bring out the sample space once again. Okay. It is numbered from 1 to 6, 1, 2, 3, 4, 5, and 6. So, obtaining the number 5. How many 5 do we have here in the sample space? There's only one 5. So the probability of obtaining 5 is 1 over 6. There are 6 sample space, 1, 2, 3, 4, 5, 6. Now, obtaining the number 8. This is impossible event because we don't have 8 in the die. So the probability of impossible event is 0. Obtaining an even number. How many even numbers do we have? 2, 4, 6. There are 3. So the probability is 3 over the total number of sample space. That's 6. And we have what? 1 over 2. Now, obtaining an odd number. How many odd numbers do we have? 1, 3, 5 are odd numbers. So there are 3 altogether. Okay. All over how many sample space? 6. Again, we have what? 1 over 2. Okay, so I've said it before, in a toss of a feather, yes, the probability of obtaining an even number and that of odd number is 50-50. That is 1 over 2. That's 50%. 50 over 100 is 1 over 2. Okay? I believe you have gotten the concept of probability. I'll leave you with assignment. But before that, remember that probability is the tendency for event to happen or for it not to happen. We apply probability in our daily life when we want to embark on a business, on anything we want to do. You ask yourself, what is the probability that I'm going to make it or I will not make it? It's very, very useful. Okay, I leave you with this assignment. For questions and comments, send it to js2@brightfuturecollege.com or send it to my WhatsApp number that is displayed on the screen for you. Alright? Send it to my WhatsApp number that is displayed on the screen for you. Alright, I'm your mathematics teacher, Mr. Emmanuel Akpan. Thank you very much for having me.